Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
This lesson is about partial fraction, which is one of the subtopics of the chapter Algebra. So in total, there are 4 different types of partial fractions. For now, we'll proceed to the type 1. Denominator with linear factor. Let's have a look at this expression, ax plus b over px plus q and rx plus s. You notice that the bottom part here, both the factors are linear, means x with power 1. So you need to know how to split this into fractions of the form a over px plus q and b over rx plus s. You notice that for the first fraction here, the bottom part px plus q is the same as the first linear factor. For the second fraction here, b over rx plus s, the denominator is the same as the second factor here. And what's the function of a and b? We are supposed to find out what's the value of a and b. They're both constants. Alright, so I explain further by using an example. So for now, let's try to find the partial fraction of this fraction. You notice that for this denominator, it's both linear factors. So we can split into 2 fractions, where the bottom part, one is x minus 1, the other one is x plus 2. Then I just put a and b on top to represent the constants. So we are now supposed to find out what's the value of a and what's the value of b. So the steps are very simple. You just need to combine them into one single fraction. So the upper part, a, you just need to multiply with x plus 2. For the b, you multiply with x minus 1. Then you compare it with the left hand side. Alright, so you notice that the denominators are the same, so we can cancel both. Then form a new equation. Alright, so during the exam, if you want to save the time, actually you can skip this step. Okay, so for now, how to find out the value of a and b, the constant a and b? To be faster, we can sub in the value of x into both sides, sub into the both left and the right hand side. So what value of x to sub in? You got to find out a value of x that make the factor become 0. So now let's say I want to make this factor become 0, x plus 2 becomes 0. I got to sub in the value x equals to negative 2, yes. So when I sub in, I have to sub into both left hand side and right hand side. So let's say now negative 2 I sub into the left hand side. 7 minus negative 2, I'll get a 9. And the negative 2, when I sub into the right hand side, negative 2 plus 2 here will make the factor become 0. So 0 multiplied with a, you still get a 0. So the a will be gone. And then negative 2, when you sub into here, negative 2 minus 1, you get negative 3. So it's actually negative 3b. From here, we can conclude that b is negative 3. Alright, so we found out the value of b. So now left with the value of a. So we find out another x value to sub in. So to be easier, we try to make this factor become 0 by substituting x equals to 1. Alright, so x equals to 1, we have to sub into the left hand side and the right hand side. So for now, we sub into the left hand side. So when x equals 1, 7 minus 1, you get a 6. So when I sub into the right hand side, here, 1 plus 2 is 3, so you get 3a. And for the x equals to 1, when I sub into this factor here, 1 minus 1 becomes 0. 0 multiplied with b is still a 0. Alright, so from here, we can get a equals to 2. That's how we find out the value of a and b, which means now we can conclude that our partial fraction will be 2 over x minus 1 minus 3 over x plus 2. Alright, simple as this. This is how we express this fraction into the partial fraction. Alright, this is a type 1. Alright, let's proceed to the type 2. Type 2 is the one that the denominator is a quadratic factor. Let's have a look at this expression. Alright, so you notice that the denominator here, the first factor is a linear factor. And for the second factor here is a quadratic factor, means the x with power 2. So you need to know how to split this into partial fraction of the form a over px plus q and bx plus c over rx squared plus s. Alright, take note here, for the first fraction, the bottom part here is a linear factor, and that is why the upper part here, I'll just put a constant a, which is the same as the type 1. But for the second fraction here, the denominator is rx squared plus s, which is a quadratic factor. So for the upper part here, other than a constant c, we need to add in the x term with the coefficient b. So it's bx plus c when the denominator is quadratic factor. Alright, so this is general form. So the method of solving is exactly the same as the type 1. So I will not illustrate further on this type, and I'll just continue with the type 3. Type 3, denominator with a repeated linear factor. Have a look at this expression. For the bottom part here is made of two factors, where the first factor here is a linear factor, which is the same as the type 1. For the second factor here, rx plus s power 2, we call it repeated linear factor. The one inside the bracket here is linear and is squared outside here. That's why it's called repeated linear factor. Alright, so you need to know how to split this into partial fraction in the form of a over px plus q. This one is the same as the type 1. And for the second factor here, rx plus s power 2, you need to split into two fractions, where the first fraction, the denominator is the same, exactly the same as the rx plus s power 2. And the third fraction, you just need to put in rx plus s without the square here. And for the upper part, we just need to put constant, constant, and constant. So I'll just represent by using ABC. So the method of finding the constant ABC is actually the same as the type 1, but there's something to take note here. So I'll explain further by using a passive question. Have a look at this question. Part 1. You are asked to express the fx in partial fraction. Alright, so you just need to check at the denominator. For the first factor here, it's a linear factor. For the second factor here, it's a repeated linear factor. So how are we supposed to do it? The method is the same as the type 1 I mentioned just now. Alright, for this type, you just need to split into three fractions. For the first fraction, the denominator is the same as the first factor, which is 2 plus x. Second fraction, you follow the second factor with a square. Third fraction is the same as the second factor, but without the square. Alright, so for the upper part, I'll just put a, b, and c to represent the constant. So we are now supposed to find out what's the value of a, b, c. And what students usually do, here's how they will do it. A multiplied with the other two factors, isn't it? 3 minus x squared and 3 minus x. And the b will multiply with 2 plus x and 3 minus x. And the c multiplied with 2 plus x and 3 minus x squared. But this is a common mistake made by the student. The actual way is this. I'll change the color. Alright, so the actual way is to combine it into a single fraction like the type 1. which is 2 plus x, and 3 minus x squared as the denominator. And for the upper part, what should we multiply for the a? Have a look at the a's fraction. It's a over 2 plus x. So after you combine, it's just leg of the 3 minus x squared, which means the a, we just need to multiply with 3 minus x squared only, without the 3 minus x here. Alright, so for the b, look at the fraction b over 3 minus x squared. If you compare with what we want here, you're just left with the 2 plus x factor, which means the b just need to multiply with 2 plus x. So this is the extra one. As for the c, have a look at the c here, c's fraction. The bottom part we have 3 minus x, which means we need one more here, one more 3 minus x, and 2 plus x as well. So the c got to multiply with 2 plus x and 3 minus x. Alright, so the actual equation is supposed to be 16 minus 17x equals to a multiplied with 3 minus x squared plus b multiplied with 2 plus x and c multiplied with 2 plus x and 3 minus x. This one is the actual equation that you're supposed to form. Please take note here. So for this type 3 is the one that usually students will make mistake. Alright, so the method in finding the ABC is exactly the same as the type 1 now. Okay, so let's say now we want to make one of the factor become 0. So let's say I choose this factor here, 3 minus x. To make the 3 minus x equals 0, we are supposed to sub in x equals to, yes, you sub in x equals to 3 into both sides. So for the left hand side, when you sub in x equals to 3, you will get negative 35. And for the right hand side, when you sub in x equals to 3 into this factor, it becomes a 0. 0 multiplied with a is still a 0, so the a is gone. Alright, let's look at the second one. 2 plus x. So when I sub in the x equal to 3 here, I'll get 5. So I'll get 5b. Okay, let's look at the third one. X equal to 3, if I sub into here, I'll get a 5. But when x equal to 3, when I sub into here, I'll get a 0. 0 multiplied with anything will be still equal to 0. So the c is gone. So from here, I can find out the b easily, which is negative 7. Okay, now let's sub in next value for the x. Alright, so let's look for the next factor here, which is 2 plus x. How to make the 2 plus x equal to 0? We are supposed to sub in x equals to negative 2, yes. So when we sub negative 2 into the left hand side, we will get 50. Right? So now we are supposed to sub the value of negative 2 into the right hand side. So negative 2, I sub into this factor. 3 minus negative 2, I get a 5. 5 squared, 25. So it's 25a. Alright, negative 2, now I sub into the second one here. 2 minus negative 2. 2 plus negative 2, sorry. It will be equal to 0. So the b is gone. Then the third one, same thing. When I sub negative 2 into here, 2 minus 2 is 0. So the whole thing here becomes 0. So the c is gone. From here, we can find out the a equals to 2. So now we have found out the a and b. We are supposed to find out the c as well. But notice here, all the factors are used up. This factor, when I make it equal to 0, we sub in x equal to 3. For this factor, when I make it equal to 0, I sub in x equal to negative 2. And these two factors are the same as the previous two. So what to do now for the x? Actually, we can sub in any x values that we want. Just that when you sub in 3 and negative 2, you find the a and b faster and easier. So now let's say I sub in any value of x that you want. I sub in, let's say to be easier, I sub in 0. So when I sub in 0 into the left hand side, I get 16. When I sub in 0 into the right hand side, 3 minus 0 squared, I'll get 9. 9a. Alright, so sub 0 into here, I'll get 2. So it's 2b. Then sub 0 into these two values here, I get 2 times 3, which is 6c. Alright, so since we have this equation already, we can sub in both the a and b value that we found out earlier. So 16 will be equals to 9 times 2 plus 2 times negative 7 plus 6c. So let's calculate the value for the c. Alright, you get a 2 for a c. Okay, which gives you what's our final answer for the partial fraction? Have a look at the ABC here. This is a, this is a b, and this is a c. So you are supposed to sub in the values into the ABC. Alright, so the final answer will be 2 over 2 plus x minus 7 over 3 minus x squared plus 2 over 3 minus x. This is the final answer for the partial fraction. Alright, clear? Alright, so if you are clear with all the type 1, type 2 and type 3, then we'll proceed to the last type. Type 4. The degree of the numerator is the same or higher than the denominator, and we call it improper fraction. This is type 4. Alright, look at here. When the degree of the numerator is less than the degree of the denominator, the fraction is said to be proper. Look at this example. At the upper part here, the degree is power 1. And for the bottom part here, when you multiply the x and x together, you get x squared, which means the degree is 2. So the degree at the upper part 1 is less than the degree at the bottom part here 2. We call it a proper fraction. Alright, for the second box here, when the degree of the numerator is the same or higher than the degree of the denominator, the fraction is said to be improper. Alright, so I have a look at the example there. 8x squared minus 12 over x minus 1, x minus 3. So the degree at the upper part here is a 2, and the degree at the bottom part here is a 2 as well. So they are the same, which means this fraction is an improper fraction. Have a look at the next one. 8x cubed, the degree is a 3, and the bottom part, the degree is x squared, so the degree is a 2. So 3 is more than 2, which means this is also an improper fraction. So before we do the partial fraction for improper fraction, there's one important step, which is, have a look at the note here. You have to carry out long division before you start doing the partial fraction. Okay, so this is type 4. I'll illustrate further by using a passive question. Alright? Okay, have a look at this question. Part 1, they ask you to express the function in partial fractions. So usually what students do, they'll just look at the denominator here. The first one, it's linear. Second factor here, it's also linear. So most of the students will say that, alright, so this is type 1. Then they will straight away proceed with the type 1 procedure. But that's wrong, because if you notice, the degree at the upper part here is power 2. The degree at the bottom part here is also power 2, which means this fraction is improper fraction. So when it's improper fraction, what should we do to make it proper? We have to do long division to make it proper. Then only we can continue with the partial fraction. So when we continue with the partial fraction, then only we can figure out whether it's type 1, type 2, and type 3. Alright, so type 4 is the special one that you need to take note. And how are we supposed to do long division? Alright, let's say for this example, we have noticed that it's an improper fraction. So the first step is to do long division. So before we can do the long division, you have to expand the bottom part. Make it into 3x squared and minus x minus 2. Okay, so 12x squared plus 4x minus 1, we are supposed to put inside here. 3x squared minus x minus 2 have to put outside here. So for the long division, you learn further in the polynomial chapter. Okay, so the first value that you've got to put here, it's a 4 to make it a 12x squared. Then we are supposed to take the upper part minus the bottom part. So 12x squared minus 12x squared, that will be gone. 4x minus negative 4x, it will be 8x. And negative 1 minus negative 8, it will be a 7. Alright, so how are we supposed to arrange this? It will be equals to the quotient 4 plus the remainder 8x plus 7 over the quotient, which is 3x squared minus x minus 2. Okay, so now we'll notice that for this fraction here, it becomes a proper fraction because the power at the upper part here becomes 1. The power at the bottom part here is a 2, 1 over 2. So it becomes a proper fraction. So when it becomes a proper fraction, then only we start doing the partial fraction. Okay, so how to do the partial fraction? For the denominator here, we will need to factorize it back to the original form. Okay, so the 8x plus 7 is supposed to be over x minus 1 and 3x plus 2. Alright, then now we need to figure out whether it belongs to type 1, type 2, or type 3. And obviously, it is type 1. Okay, so you can just solve it by using the type 1's method that I have just taught you. Alright, so this is all about type 4, the special one where usually students will make mistake. Alright, you have to take note here. I'm not going to show the steps on how to get the final answer here, as it's the same as the previous questions, but of course you can try it yourself and check for the final answer. The final answer is given here, part 1. Alright, have fun, and that's all for today's lesson. Thank you.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.